Okay, so yesterday when we left off, we made this, right? That's what we made. This is the tree diagram for this problem, right? So you can see the top. So for a person who's 13 to 24 who likes pop, 40% chance. For a person who's 13 to 24 years old who doesn't like pop, or whose preferred music isn't pop, is 0.07, so on and so forth, right? For 25 to 34, there are 1, 2, 3, 4, 5, 6 different outcomes that could possibly happen, right? You can be 13 to 24 and prefer pop. You can be 13 to 24 and not prefer pop. You can be 25 to 34 and prefer pop. You can be 25 to 34 and not prefer pop. You can be 35 or older and prefer pop music, or you can be 35 and older and not prefer pop music. Okay, so those are the 6 things that could happen. Nothing else can happen. Okay, so based off of that, let's answer these questions. What is the probability that someone likes pop? So what's the probability I put all those people's names in a hat and I randomly pick one out and that person likes pop?
What do you guys get? Because I think I got 6.14. Okay, good. Okay. What do you guys get?
Were we supposed to do some homework?
Okay, so
Well, I mean, not like official homework, but we're gonna go through.
So I don't necessarily care what the answer is because I don't know if that's right or wrong. What I care about is the process to get there. So, okay, there you go. Now you're talking. So we add up all the yellow paths.
Yes.
Okay, so we add up all the yellow paths. So we got 0.40. We add up 0.148. 148. 0.064. And those are all the paths that give us a preferred music as pop. And then what'd you guys get?
0.612.
612?
Yeah, this is a rounding error. Yeah, this was a rounding error. Or close.
Okay. So when you add up those 3 numbers there, you get 0.612?
No, I got 0.6114. Because I didn't round
Oh, okay.
the tree diagram one. No, that's still right. 6.614 is right on yours. Because you rounded up the values. I didn't.
Okay. I got you.
Like on the tree diagram, I didn't round up the values. I kept them as I found them.
614?
Yes.
Okay. Okay. There we go. All right. So how would I find out the probability that people's preferred music isn't pop?
-1.
There you go. Right? Or I can add up the other paths, right? What color did I use?
Orange?
The other paths. Yeah, that orangey color. I could add up the orangey color. Okay. It would still be the same thing. Okay. Suppose a person chosen identifies his or her favorite music as pop genre. What is the probability that he or she is age 13 to 24? Well, I wrote it on here, which is I hope what you guys did or would do is they tell you what's the given. We already know. We already know that the person that's going to be chosen is pop music genre. That's what we already know that. So they're asking what the probability is that person's also 13 to 24. So anytime you have a given in words, in symbols, you automatically go to the general multiplication rule. Because that's how we're going to solve it. Okay? So the general multiplication rule says the probability of both of these things over the probability of the second one, which is pop music. We just found out the probability of pop, which is 0.614. Now we have to find the probability of 13 to 24 and pop. That's one of my paths, right? That's a path down the tree diagram. That's this path right here. 1324, so it should be 0.40. Okay. Division, and what do we get?
0.6514
6514.
or 65.3.
Yes, that's the same thing I got.
65.3.
That's the same thing.
Yeah, it was. Yeah.
Okay. All right.
Oh yeah, that's what I had a question on.
Yes.
Well, on the testing,
Uh-huh.
like on the AP test, right?
Yes.
They take away a point for like major arithmetic error. What counts as a major arithmetic error?
Here's the thing. If you set this up like this, if you set it up like this, and your answer is wrong, they give you full credit. Because
you got the setup right.
exactly.
Okay.
That's why.
Calculator's fault.
So one of two things had to happen. The calculator, you pushed the button wrong, right, in the calculator accidentally because you're going too fast, or you tried to do it by hand and you made a mistake somewhere. That's not what we're testing, right? They're testing to see if you did the setup correctly. So yeah, that's a great point. That's why I've been harping from day one to show your work, because if you do make those little baby mistakes, it doesn't count against you because you did everything right. When you guys do FRQs, that's what I do, right? I look at your answer, and if your answer makes sense, I go look at your work, make sure that makes sense, I give you full credit. If your answer is wrong, I see, how in the world did you get that answer? And if it makes sense, then I'm like, oh, they just made a calculation error, right? Give them full credit. Okay. So yeah. Mm-hmm. So that's why the setup is so important, because it could be the difference between passer getting full credit or not getting full credit. Okay. All right. So let's skip the next question, because the next question is very similar to one we already did. Let's go to the snoring question. The last question, snoring. So yeah, this is the first thing we're going to do here is you're going to read the question. Read the question. Tell me, is it a Venn diagram, tree diagram, or table question? That's the first thing I want you to tell me.
Well, if it's a tree diagram, it's also a table.
So visualize it in your head. Which one do you think would help you solve this one? A Venn diagram, a tree diagram, or a table? Talk about it with the person closest to you. So what do you guys think?
Tree or table?
Tree or table? Okay, this is what we're going to do. Do both. Don't answer the question yet. Don't answer the question. I just want you to make a tree diagram for this problem first, and then make a table for this problem as well. Do both. You got some blank space there. Do both. And then if you finish those, you can go answer the question. Okay, so
You did like that?
yeah, I did both. I did a two-way table and a.
What I mean is, you flip, no, on the table you flip the thing.
Oh, the variables. Yeah, as long as you have snoring and no snoring as on one side, and greater than 30 or less than or equal to 30, it doesn't matter if you flip these or not. Okay. So I started with the tree diagram, and the problem was that they didn't tell me anything about less than 30 and whether they snore or not snore. Doesn't tell me anything about it. Mhm. There you go. Yeah, you have to use a little bit of critical thinking, right? Because they say 38% of everyone snored, and I know that these guys are part of the snorers, right? So whatever I need there, I can figure out what would be here, right? You can do that deductive reasoning. That works. Um, but when I did the table, it made a little more sense to me because I could put the 38.8 at the end. I should have put that. 38.8. That should be an 8. Okay. So then snores. So here's the thing though. How do I get this number and this number here? How do I get these two numbers? So 0.388. So this number, you're saying this number right here goes there? So this is snoring, and that's the answer. So this one right here is the answer to this path here. So this path here is right here, right? So the answer here is going to be 0.068. That'll be the answer here. But to get this guy here, I have to do what? So watch, this is what I, let me say it again. So to get this answer here, that is going to be the same as this answer here. That's the answer. We know the answer. For snores and less than or equal to 30, that number is 0.068. There you go. That's what we're going to do, right? Because I'm going to multiply this guy times this guy to get this guy, right? Well, the opposite of multiplication is division, right? So this guy times x equals this guy, divide by this guy. So 0.068 divided by 1.85, and we get 0.368.
How would you get that
Without having the table, let's see. This is what I would do. Without having the table, that's a great question. So let me take this and make another. So I'm running out of room here. Copy. Let me add another page. Copy. Okay, so there we go. Okay, so what I would do, so let's say I didn't have this. Yeah, so let's go back a few steps and say I didn't have these guys here, right? And I didn't do a table. All I did was this. How would I come up with these two blanks here? This is what you would do. They do give us enough information, but you just have to use division, right? They say at the beginning, the probability of being a snorer was 0.388, right? That was the probability of being a snorer. That means when I add this guy and this guy here, so here I would do 0.815 times 0.321, right? and I get 0.815 times 0.32, 0.261. Okay. So I know I'm missing how much? What part am I missing? I can subtract those, right, to figure out what this equals? Because those are the only two ways to be snorers, right? Okay. That's the only two ways to be snorers. And if the total snoring is 0.388, and I know I already accounted for 0.261, the rest has to come from this path here. So I go 0.388 minus 0.261, and I get 0.127. Wait, that's not the right one, though, is it? Is that what we said earlier?
No.
No. So where did I go wrong here? Where are my numbers off? Probability of being a snorer is...
You could subtract 0.32 from 0.388 and you get 0.068. And you divide 0.068 by 0.185.
Say it again. Say it one more time.
I don't know if I'm right, but you could subtract 0.32 from 0.388 and you get 0.062.
Mm-hmm.
And then you divide 0.062 by 0.185. And then you get the branch number.
Oh, you do?
I think so.
Let's see. Okay, so snores, 0.388, right? So 0.815 times 0.32, 0.261. Subtract that from the total number of snores, and I get 0.1272. So then 0.127 divided by 0.185 is 68.5, which is not what we got. From there to there, I made some sort of mistake, but I can't remember. I can't see which mistake I made. Well, let's see. I could do it this way. Okay, so let me go this way. If I go that way, I get 0.815 times 0.68, 0.554. Okay, so if I add that with 0.261, uh, 185. Let's see. And then 1 minus 0.388 minus 0.554. This should be 0.058.
Is your table off?
My table might be off. I didn't even check my table.
.068 plus 0.125 is not 0.185.
Which one?
Go to the table.
Let's see. Here, so I can get confused. Table. Which part?
0.68 plus 0.125. It's 0.193.
This is 193.
Should be.
Is that part of what?
I think you no snore under 30 and no snores off because I have 0.117
Okay,
instead of 0.125.
let's try. Let me erase all of these and start from scratch.
Yeah, let's put it from scratch. That sounds like a great idea.
Okay.
You know, hard to
So we know that 85.1% or over 30, right?
Hold on. All right, where are we starting?
81.5% or over 30.
Yes.
So
that's
that
a given?
means,
Is that a given? That is a given. Okay.
185.
there you go. All right.
Okay.
Okay. Next piece of information, 38.8% of all adults snored.
Okay.
So that means 0.388 has to go down here, right?
Yes.
That makes sense
Okay.
to me.
32% of the respondents were snorers over the age of 30. So that means 0.32 has to go in there, right? Okay. So then let's use a little bit of.
32% of something.
It says of all of the respondents were snorers over the age. It says the way it's worded, it sounds like it's of all respondents, right? Of all.
You would get like 32% of something.
Yeah. No, I know what you're saying.
Like the one that was on the homework that
Mhm.
said like the weather one.
Yeah. I see that, but it's just the way that it's worded makes it sound like it's out of all, right? 32% of the respondents were snorers over the age of 32. So we try, yeah, let's try it that way then. Let's try it of. So what's 32% of 0.388?
0.388 times 0.32.
Mm-hmm.
I think it's saying it's
0.124.
And I think that's the number we got, right?
I thought it was a 1.74.
Close. Was that the one that? I don't think that's the one though. No, that's not even the one, right?
I don't think so.
your chart. I think your chart was just off.
Okay. So you want to go back the other way?
Yeah, let's try 0.32 first.
0.32. So this is 0.068.
Yes.
Okay. Which is the number we got here. Okay. Which is the number I have. Which is the number I had up there. And then no snore over 30 was what?
0.495.
495. Okay.
Wait, how'd you get that?
You subtract 0.32 from 0.395.
Minus 0.068, 0.117.
Yes.
And if I add those two, do I get 0.185?
Yeah.
Plus 0.495, 0.612?
Yep.
Okay.
That makes sense.
All right.
Now
we can answer the questions.
Now we could be getting somewhere. Okay.
All right. So which percent of the respondents were under 30 and did not snore?
Under 30. 0.7 or 0.117?
Yep.
0.1. Oh no, percent. 11.7%.
Okay. Is snoring independent of age?
I really don't want to.
Probability of snore given an age. So pick an age. Over 30?
Sure.
Should equal the same as the probability of snoring. If those are correct, if those equal each other, then they're independent. If they're not independent. So the probability of snoring is 0.388. The probability of snoring, given that you are over 30. So we have to, it's given. So it doesn't matter. We could check both. Because if one shows independence, the other has to show independence. If one doesn't show independence, then they both won't. So we can check both if you want, but I'm just trying to. Okay, so that means we have to do probability of snoring and over 30 over the probability of over 30. So snoring and over 30 is 32%. Over 30 is 0.815. So when I get those, what do I get? 392, very close, but not the same.
0.388. You get 0.388. Oh, okay. Wait, snoring and over 30 is 0.388.
Snoring? Just snoring is 0.388.
No, but I thought it was probability of snoring and
Over 30?
yeah.
0.32. Probability of over 30 is 0.815.
Right.
So I divided those. Came out very close, but not close enough. If it's close enough with a rounding situation, then it's okay. But this one is dependent. That means if you tell me their age, it's going to tell me a little bit about whether they snore or not.
And the probability of snoring is 388.
We could check the other way. You want to check the other way?
No.
You want to check another age?
No. Well, if one works, the other works.
Well, yeah, but I'm saying to have it in your notes.
Absolutely.
No.
Check the other age. There's only one other age.
You know
Probably.
what, let's do 16 to 12.
Ah, yes.
Okay.
Less than one.
So less than 30. So probability of a snore is still 0.388. And then this one over here, the probability of both snoring and less than 30.
0.68. 0.068.
And then the probability of less than 30. So the probability of less than 30 is what? 0.185. And the probability of both snoring and less than 30?
0.068. Point 367.
Again, it's very close, right? 368, but not the same. Okay.
So how did we mess up the first time?
I think the table was off.
I think instead of 0.117 was a different number. I'm pretty sure.
What's the table look like right now?
Before
Oh, that's 117.
Yeah, I think the table was off.
But I can't tell.
So the reason I had you do both was because sometimes one's easier than the other. Anytime you can use a tree diagram, more than likely you can use a table. So it doesn't matter to me which one you use. I'm not going to say use a table. I'm not going to say use a tree diagram. What I'm going to say is answer the question. And if you don't have one of those, it's going to be harder to answer the question.
So how do we figure out the difference between percent, like the perception, the win question on the homework, and then this kind of question, where you just take the thing.
Let's see this problem. Let's do this problem. We got one more. We got one. Let's do this problem, and then we'll see if that question comes up. And if it doesn't, we'll tackle it. Okay. So A and B. A student studies. 50% chance. Wow, only 50% chance a student's going to study. B, student does well on the test. Let the following be true. Student probability of student studies and does well, 35%. Probability of student studies and does poorly on the test, 15%. Probability student doesn't study and does well on a test, 5%. Probability student doesn't study and does poorly on a test is 45%. So what is the probability that the student does poorly given that he or she didn't study? Given that, right there, given that, okay? So really, they give it to you. Really, the percentage they give it to you, that's really a table right there. It's just in words instead of table form. So what we're looking for is the probability given that. So what's the probability that they do poorly? Given that no study. All right. So that means the probability of both over the probability of no study. Okay.
0.45 divided by 0.5.
So the probability of both poor and no study, is 0.45. Right there. And the probability of no study. Yes, 0.5. Right? There are a couple ways you can do it. You can add up these two numbers here because those are the only two paths where it doesn't study. Or at the beginning, it says, hey, 50% of them study. So that means the other 50% can't study or didn't study. So 0.45 divided by 0.5.
0.9.
So given that a student didn't study, what's the probability they don't do well on the test? 90% chance. Pretty high. Last one, what is the probability that any student does well? Any student does well.
0.35, 0.05. Because you add up the two lines that they did well.
You go find the true paths that they did well. They did well right here, and they did well here. Those are the only two paths where they did well, right? So you add them together. 0.4. All right. Okay, so next week we are going to do a little bit of review. I'm not going to give you an assignment over the weekend because we're going to do it in class on Monday. Okay, so I'm going to give it to you on Monday. Tuesday, we're going to do a little bit of review. Probably Wednesday group tests. If it's I'll post it on Google Classroom. I can't remember if I gave in past years if I gave a test for chapter 5 or a quiz. Pretty sure it's a test. So group test probably on Wednesday, and then Thursday and Friday we'll have the multiple choice and FRQ. Okay, so Monday and Tuesday we'll review. All right.